Hello everyone, myself Dr. Santanu Kundu. I welcome you all to this lecture of soft computing techniques. This is the second lecture of module 9. So in the first lecture, we have studied the introduction part of RAP set theory. So RAP set theory was developed by J. Pollock in the year 1982, that is early 1980. So the main goal of the RAP set analysis is induction of approximations of concepts. RAP sets constitutes a sound basis for knowledge discovery in databases, that is known as KDD. It offers mathematical tools to discover patterns hidden in data. It can be used for feature selections, feature extractions, data reductions, decision rule generations, and pattern extraction. Recent extension of RAP set theory, that is known as RAP methodology, have developed new methods for decomposition of large data sets, data mining in distributed and multi-agent systems, and granular computing. The basic concepts of RAP sets, information tables, and another one is decision systems or decision tables. The concept of indiscernibility, set approximations, reductant core, RAP memberships, and dependency of attributes. So first one is that information systems. So information systems, IS, is a pair of objects and attributes. So here the elements which are in row are objects, in columns these are known as the attributes. So U is a non-empty finite set of objects. So here x1, x2, x3, x4 are the objects, and attributes are age, and one attribute is LEMS, that is associated with some leg disease. So A is a non-empty finite set of attributes such that there is a mapping from attributes to VA, where VA is the value, so that is known as VA. So here you can say that objects are x1, x2, x3, x4, x5, x6 and x7, and attributes are age and the LEMS, and the value, these are the values, VA, these are the entries are the values. So VA is called the value of A. Now try to understand the decision system or decision table. So DS, that is a decision system or table. This is table of objects, attribute with one or more decisions. So D is known as the decisions. So D does not belong to the attribute. T is the decision attribute. Instead of one, we can consider more than one decision attributes. The elements of A, that is the age or LEMS, known as the condition attributes. So these two are condition attributes. You can say work is the decision attributes. Now the issues in decision table. So the same or indiscernible objects may be represented several times. Some of the attributes may be superfluous. Now try to understand the indiscernibility. So today in this class we will try to understand the term indiscernibility. So the equivalence relations, basically a binary relations R, which is subset of some x cross x, which is reflexive. I means every element is related to itself. So x related to x for all x belong to some set A. So that is called the reflexive. Now symmetric is that if x is related to y, then y must be related to x. That is called symmetric. Now transitive is that if x is related to y and y is related to z, then x must be related to z. So the equivalence class X are open element, x belongs to x, consists of all objects, y belongs to x, such that this relation hold. Let one information table U and objects and attributes be an information system with any subset of attributes A. So B is any subset of attributes set A. Then there is an associate equivalence relation that is known as indiscriminative B. X and x1 belongs to U cross U. For all A belongs to B, these value are same. X equal to AX1. So I mean, if you write one object x1, x2, if this value is something is 3, this value is 3, so you can say these two are same. So here you can write that indiscernibility, so that becomes a class. x1, x2 is becomes an equivalence class. You can write like that. Okay. So if x and x dash belongs to indiscriminate B, the objects x and x1 are indiscernible from each other by attributes from B. So there is some attribute B you can assume here. The equivalence classes of B indiscernibility relations are denoted as XB. So you can write it is XB. So let more into this topic. So in rough set theory, indiscernibility refers to the situation where two or more objects cannot be distinguished from each other based on the available information, that is the attributes. The indiscernibility relations is used to group objects that are equivalent with respect to certain attributes. So simple data set, consider a set of objects, that is data points, with two attributes color and size. So here object O1 color is red, size is big. Object 2 color is red, size is big. Object 3 color is blue, size is small. Object 4 color is red, size is small. Object 5 color is blue and size is small. So you can say that in terms of size and color, these two are same. Red, red, big, big. This is different and this is same with this, and O4 is different. So you can write here that indiscernibility based on both color and size, the indiscernibility relation group objects that are indistinguishable when considering these attributes. So indiscernibility relation, two objects O1 and O2 are indistinguishable because we cannot distinguish them because they have identical values for both color and size. Similarly, for O3 and O5 also have the same size and color. O4 is not same with all rest of the fours. So you can write indiscernibility of color and size. So this make one equivalence group O1 and O2. This make another equivalence O3 and 5, and O4 is separate. So indiscernibility in terms of color and size is this set O1, O2, O3, O5 and O4. Now consider another example where we have three attributes: age, income and education level. This is a data set of individuals. So here some 5%, P1, P2, P3, P4, P5. The age of P1 is 25, P2 30, P3 25, P4 28, P5 25. The monthly income is 40k for P1, 45k for P2, 40k for P3, 50k for P4 and for P5 40k. Education level for P1 is bachelor, P2 also bachelor, P3 bachelor, P4 master and again P5 bachelor. So we need to try to find the indiscernibility on this case. So if you think you can understand that P1, P3 and P5 are the same group. So that can be make equivalence class P1, P3, P5 and P2 is separate, and you can also check P4 is also separate. So here we define indiscernibility here based on all three attributes. So indiscernible groups P1, P3, P5, age 25 for all three, income is 40k for all three, education level is bachelor. So these individuals have identical values for all three attributes, so they are indiscernible. Similarly, group 2 for P2, that is age 30, income 45K, education level is bachelor. So this individual is distinguished by their age and income from others. Similarly, for group 3, P4, age 28, income 50K, education level master, this person has different values for all attributes. So they form their own group. So now indiscriminity of age, income and education level. So this is the set P1, P3 for group 1, for this is for group 2, this is for group 3, like that. So try to understand one more example. So information table with two attributes. So that is the A, B, C, D objects. Color is A red, B red, C blue, D blue. Size of A small, B small, C large and D also large. So now define the indiscriminate relation based on two attributes, two objects X and Y are indiscernible if they share the same values of both attributes. So here you can see that A and B are indiscernible because they both have the color red and the size small. C and D are indiscernible because they both have color blue and size large. A and C are not indiscernible as their attributes are different. So this can be represented as A, B, one equivalence class, C, D, and another equivalence class. So indiscernibility color and size is A, B, one group, and C, D is another group. So try to understand with some large table. So here we are using 5 objects x1, x2, x3, x4, x5. Age is 25 for x1, x2 is 25, x3 is 30, x4 is 40, x5 is 40. Income is 3000 for x1, x2 3000, x3 3500, x4 4000, x5 also 4000. Now if you try, you can say that x1, x2, this from what this is also indiscernible. Similarly, x3 is different and x4 and x5 is x4 and x5 are also indiscernible. So here the indiscriminate relation based on the age and income is as follows. X1, X2 are indiscriminate because they both have the same age, 25, income 3000. X4 and X5 are indiscriminate because they both have the same age and income, that is 4000. X3 is not indiscriminate with any other objects because its attributes differ from others. So this is what first equivalence class, second equivalence class, third equivalence class. So indiscriminability of age and income can be written like this: x1, x2, x3, and x4, x5. So now try to understand more on indiscriminability. So here there are 7 objects: x1, x2, x3, x4, x5, x6, x7. Age is for x1 16 to 30, x2 is 16 to 30, x3 is 31 to 45, x4 is 31 to 45, x5 is 46 to 60, s6 is 16 to 30, x7 is 16 and 30. So if I write directly indiscriminability of age, you can write here x1, then x2, then x6. Then x3, x4, then x5, x7. Similarly, we try to write another one. So suppose the leg disease, that is LEMS. So indiscriminate with respect to LEMS attributes, you can find it x1 is different, x2 is different, x3, x4 make one equivalence group, and x5, x6, x7 make another equivalence class. So this is indiscriminate of LEMS. Now if we try to write both indiscriminability of age and LEMS, so here you will see that this 16, 30 to 50, nobody is there, so that is x1. Then x2 is also different, but you can write x3 and x4 are the same These are indiscernible x3 and x4, x5 and x7, and x6 is different from others. So these are the indiscernibility of age and names. So observation and equivalence relation induce a partitioning of the universe. The partition can be used to build new subset of the universe. Subset that are most often of interest have the same value of the decision attribute. Note, it is a relation between two objects or more where all values are identical in a relation to the subset of a considered attribute. So that is basically the indiscernibility. Now, in rough set theory, indiscernibility can also be influenced by missing data. Consider the following table with some missing attribute values. Here, the question mark denotes a missing value. We can still establish indiscernibility based on the known attributes. So, this is the object 1, color is red, size is big. So, object 2, color is not known, size is big. Object 3, color is red, size is small. Object 4, color is red and size is not known to us. So O1 and O3 are indistinguishable in terms of color because both are red, but distinguishable based on the size, big versus small. Object 2 and object 4 are indistinguishable with respect to size, both big for O2 and missing for O4. But O2 cannot be fully compared to O1 and O3 because its color is missing. So in this case, missing data can limit the strength of indiscernibility. So I hope in this class uh, we have understood the concept of indiscernibility. Indiscernibility. So now, for question for today's class is that you write some objects. So write objects are O1, O2, O3, O4, O5, O6, O7. Some attributes like A1, A2, you can write A3. Give some values. Suppose values are something like 1, 2, 1, 1, 2, 2, 1, 1, 2, 2, 1. So simply you can write it 2, 1, 2, 2, 1, 2, 1. Here you can write also 1, 1, 2, 2, 1, 1, 2. So these are the some values. So try to find the indiscernibility of with respect to A1, indiscernibility with respect to A2, indiscernibility with respect to the object A3, indiscernibility A1, A2, indiscernibility A1, A3, indiscernibility of A2, A3, and indiscernibility of A1, A2, A3. So try to solve these questions. Find. So these are the references of today's class. Thank you.